Alright, so we're going to have a look at smoothing in order to get better lines of best fit by kind of getting rid of some of the random variation. So you've got the notes to fill in. Here we go. So when you've got pretty decent outliers and fluctuations within random time series, it can be sometimes a bit tricky to identify if there's a trend, whether it's just it is truly just outliers or whether it is positive or negative. So what we want to do is smooth out the data to make that a little bit easier. Big picture, what we're going to do is for each y value, we're going to replace it with either the mean or the median of the surrounding points. So this will kind of flatten things out a little bit. So two techniques. The first is called moving mean smoothing. This uses the mean. Okay, so the average of a few data points. Typically we use this if the data is given to us in a table. Okay, so if you're given a table versus a graph. And you don't want any massive outliers. For this one, again, you can use it. It can just maybe not be quite as good as median smoothing. So this uses the median of several data points around a particular value. Okay, so we look at a bunch of values, find the median, and do that replacement. What's neat about this one is we can actually do it straight from the graph. So we don't need that table of values. We can actually just get the median from a graph. We don't actually need to know what the values are. So that's quite handy. And of course, median is always good when we've got outliers. All right, let's keep going. So we've got the two different types. Today we're going to focus on the moving mean. So we're going to be finding the mean, not the median of the few points, but the process is generally the same. Okay, so moving mean smoothing, getting right into it. So for the process here, for each y value, okay, I pick a y value and I replace it with the mean of that value and an equal number of values on either side. So for example, maybe if I'm looking at the third value, I might find the mean of the second, third, and fourth, or first, second, third, fourth, fifth. So it needs to be balanced on either side. Typically, this means we use an odd number of values so that the new value lines up. If we choose to use an even number of values, for example, 1, 2, 3, and 4 would be aligned with x equals 2.5. And then we have to do this process called centering. We'll deal with that later. One downside to moving mean, same with median, we actually lose some data points. Okay, so when I take, say, the first three values, I lose the first one because I don't have a value before and after it. So I do lose some of the values here, unfortunately. So here's the example we're going to go through. So randomly picked days, I guess I'm predicting the future here. We've got the temperature for 8 days. First thing we're going to do is plot it. We already know how to do that. Then we're going to get right into the guts of it, which is finding the 3-point moving means and graphing them. Then we're going to use those values to get a least squares regression, and then find the 5-point moving mean and put it on the graph as well. And then I'll show you a little program that I put on your CAS on Tuesday. So we should all know how to do this. In order to plot, I need to first convert to a time code. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And then it's a matter of just individually plotting, so 119, 222, 328, plotting all of my points, and finally joining them all with lines to make my time series. Okay, so from this, it looks like there's a negative trend, but with the 28, it's making it a bit tricky to really truly identify if it is a negative trend or not. So now we want to get into smoothing it to get rid of some of that randomness. So the data below shows, again, the temperature, find the 3-point moving mean. So how it works, I find 3 values, 1, 2, 3. Okay, when it's centered, so when I take the average of 19, 22, and 28, that's centered about 2. Okay, so I'm actually going to lose the value for the time code of 1. Okay, so I'm going to go from 8 points down to 6. Because when I take the average of 19, 22, 28, that's aligned with the time code 2. So I take the average, we should all know how to do that, add them all up, divide by the total, which in this case is 3, to get 23. So instead of it being 222, now it's going to be 223. I repeat the process for the next grouping. So going over, looking here, okay, next group, 22, 28, 18, add them all up, divide by 3. So instead of 328, now notice that outlier kind of gets knocked down, it becomes 22.7. And I would repeat that process for each group of 3. Okay, so I go to the next group of 3, 28, 18, 16, find the average of that. Okay, so find the average of that one. 20.7, 17.3, 17.3, 17.7, and of course I can't do this end one here, okay, because I would need to go 3, but there isn't a value on that side of it, so I lose that value as well. Okay, so I've just done my first 3-point smoothing. So I've replaced the values with the average of the 3 values around it. So part B continues on. It says plot the smooth data on the same graph. Okay, erase that line there. So here I've got the data that we just found. Now I need to plot it. So instead of 222, I'm plotting it slightly higher at 223. Okay. Instead of 3 and 28, quite lower, 3 and 22.7, 4, and then of course join them all with the lines. So you'll notice already that's much smoother. There's much less random variation. The peaks and valleys have kind of been smushed, so it's a much flatter line. So that was our goal, okay, to get rid of some of that random variation. That's exactly what we've done by doing this process of smoothing. Now we're going to repeat it, but so continue to use that value, but now we're asked for the least squares regression. So same data set, okay, keeping what we already have done. We've done all the work, so let's not get rid of it. Find the least squares regression. Now what's a bit funny here is, again, we notice that we don't have anything for time code 1 or time code 8. So when we do the least squares regression, it'll just be 223, 322.5. So just being aware that when you type it in, you'll notice you just have values 2, 3, 4, 5, 6, and I cut off 7. Okay? So if I do the least squares regression, we're all pros at that, menu 414, I get my A, I get my B, but of course I state my equation in terms of my variables. So I've done 4 significant figures there. Okay? So you should already be completely confident finding least squares regressions. One thing you have to do is just make sure that you get rid of 1 and 8 because they don't have any Y values. So that's just a little extra work for you. Okay, so I've got my time code in there as my variable, so now I can go ahead and make all sorts of predictions. So I could predict the next Monday by plugging in time code 9. I could predict the next Tuesday by plugging in time code 10 and so forth. So this is likely a better predictor than the least squares regression of the full data where I've got that 28 that's a bit funky. Alright, big work, finding 5-point mean. Now because it's 5 points, we're actually going to lose quite a few values here. Okay? Because if I'm doing those 5 to start, that's centered about 3. So I'm actually going to lose both 1 and 2. Okay? So the value that I get will belong at the time code of 3. I find the average of those 5. Ta-da! That equals 103 over 5, which is 20.6. I repeat the process for the next group of 5. So I find the average of 22, 28, 18, 16, and 18, which is 20.4. I go to the next group of 5, next group of 5, and then I run out. Okay, because if I do this group of 5 here, that belongs at time code 6, so I'm left out for time code 7 and 8. So those are both left out, hence are left as an A. Okay, now let's get to the second part of this question, which is plotting this data. So really I only actually have 4 points, so we'll go ahead and graph those. Let's erase. Okay, so what we want to have a look at now is plotting these points. So again, I don't have anything at 1 or 2. My first point will occur at 3. So 3 and 20.6, 4 and 20.4, 5 at 19.6, 6 at 17.4, and then I connect all of those. We notice this is incredibly smooth. Okay, so there's no bumps. It's very smooth. There's a clear negative trend, but I only have 4 points. So it's a little bit of give and take. It's a really smooth curve, but I lose a lot of my data. Okay, so that, as with anything, there's always a little bit of winning and losing. So just kind of a couple final points here. There's a bit of a funny thing where sometimes they just ask you to use the last smooth value to make your prediction. It's not overly accurate, but it's something. But the better way for sure is to find the least squares regression and use that to do your predictions. Okay, so sometimes, for example, to predict time code 9 here, we would just say it's 17.4, which of course isn't a very good prediction, but it's something. All right, let's have a quick look at the helper program that we've created to help you. Okay, so it's called Smoothing. It'll be, I think in your folder it might be called Smoothing Read Only. So it's in the 2017 time series folder you should have all gotten on Tuesday. If not, try to transfer the file from someone else by borrowing a cord. So what we're going to do is just go through each of the pages and see what they do. So the first page is the instructions, 1.1. 1.2 is where we're actually going to select the type of mean smoothing or median smoothing that we want. So you simply put a 1 beside the type of smoothing that you want to do. Okay, so you put a 1 beside the one you want and delete any other ones. There's also a spot for decimals in cell C1. Typically I set that to about 4 decimal places just in case. 1.3, that's where I put in my data. So you're only ever going to put stuff in this data column, in the yellow cells. So you'll enter your data. I've entered the data that we were playing with. So going up the last little bit there, 16, 18, 18, 17. Punch the data in 1.3. The magic happens in the next page, 1.4. Okay, those values should look pretty familiar. Okay, 23, 22.7, 20.7, 17.3. Those were our smooth values, so it gives us to those automatically. This second column you'll use in period 2 when you're looking at the centered data. Okay, so that's not relevant just yet, but when we're smoothing over an even number of points, we're basically going to have to smooth twice because these aren't going to actually align, so these are the ones that align. And then on 1.5, you've got a beautiful page with your graph. You may need to menu 5.2 to get the view to adjust a little bit. Something I've added on yours is 1.7 is just a spreadsheet page, so you can use that to do some linear regressions. Because from this page here, you can't do the regressions because time keeps going on forever, keeps changing on me, whereas the data doesn't. Okay, so maybe let's have a quick look at that on the actual CAS. Okay, so let's have a look at the actual program on the CAS. So this page gives me all my instructions. If I read through, again, it gives me all the details that I need. This is the kind of where you make your choice as to what type of smoothing. So you just pick whatever the question tells you, typically 4 decimal places. And then if there's a 1 anywhere else, delete it. I've put the 1 beside 3 means because I want to do 3 means smoothing. 1.3, and I've done some movie magic. I've already typed in my data. 19, 22, 28, 18. Okay, make sure there's no other data that's left below it. So if you've got a really small data set, you might need to delete something. Just never touch the time. That's built in. And then these numbers should look familiar. Okay, we've got our 23, 22.7, 20.7, 17.3. So those were the values that we got when we did the smoothing by hand. They're just sitting right there for us. Again, this center column we'll use when we're smoothing over an even number, because if I was to smooth these over 4, it would align with 2.5. Okay, so then I would have to basically smooth again over 2 to get it to line back up with the actual value. That's what you'll do in the second period, so you'll use that later. Again, that's not a very good view. Menu 5.2, I get a beautiful view. That's for the centered data, so I don't need that. And then here I've got my least squares, if I go back copy this data. So copy all of that over, copy, and now I'm going to paste. Oops. Okay, so there's my smooth data. The time codes were 2, 3, 4, 5, 6, 7. I call this T for time code. Maybe call that, so T is already stored, TEM smooth for smooth temperature, temps. Okay, enter, and then I can just do my menu 414. There's going to be a few things already stored here. I'd save mine as T and temps. Okay. Click OK. And I should get that same equation that we got, maybe slightly different because I've got more decimal places, but that we got earlier. So that's how to use the program. It's very helpful. I highly recommend getting used to it.